Okay. Hello. Yeah, my
Yes,
my
sir.
voice is
Hello, sir.
my voice is audible, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So my screen is also shared. You are able to see, right?
Yes, sir.
Yes,
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 sir.
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 Yes, sir.
Okay. Okay then. So till now we have discussed regarding KCL, KVL, resistance combination series and parallel, and voltage division and current division rule, and how to calculate the power absorbed or power delivered by different elements in a circuit. Okay. So these are different methods or analysis techniques what you have studied till now. Okay, so there are two more methods which are called as nodal analysis and mesh analysis based on KVL. Maybe something was written wrong here. Okay, so based on basically KCL. Okay, so if you see point two mesh analysis based on K something was written, it is a printing mistake. Okay, based on basically KVL basically. Okay, right. So sorry for that. This mistake is there. It is basically nodal analysis is based on KCL and mesh analysis is on KVL. Okay. Right. Okay. So nodal and mesh analysis, these two analysis are there. These are also some analysis techniques for your circuit. Okay. Right. So nodal analysis is based on Kirchhoff's current law and mesh analysis is based on Kirchhoff's voltage law. Even something was written wrong here. Basically, mesh analysis is based on Kirchhoff's voltage law. Okay. So what is nodal analysis? Okay. Nodal analysis is used for circuits with more number of nodes. Okay. If there are more number of nodes, this analysis will be simplify your analysis process. If you use this technique, it will be easy to solve. Okay. An n node circuit will need n minus 1 voltages and n minus 1 equations. Did you study this methodology in your previous plus 2 or somewhere?
No,
Yes,
no, sir.
sir.
No, sir.
No, sir.
No, sir.
Yes,
Okay.
sir.
Okay. So some people might have got some ideas, but some might have not got idea. Anyway, we will discuss these things. Okay. So nodal analysis is basically similar to Kirchhoff's current law. Okay. Only thing is this method is very useful when you have more number of nodes. Let's say 4 nodes, 5 nodes, or 3 nodes, whatever it may be. Okay. So in that scenario, it will be useful for us to solve. Okay. So to know the node voltages, you require. So why I'm saying n minus 1 is if there are n nodes, one will be considered as reference node. Okay. Reference node voltage potential is always mostly we assume to be 0. Okay. So we have to find out the voltages of other nodes excluding the reference node. That means n minus 1 nodes. Okay. With respect to your reference node. So that means you are finding the voltage of all non-reference nodes with respect to your reference node voltage. Okay. So to know that, you have to get n minus 1 voltage equations or n minus 1 equations to find out n minus 1 voltages. Okay. We'll go to a simple example here. So if you see here in this circuit, okay, how many nodes are there as far as this circuit is concerned? If you see this circuit, how many nodes are there?
4 notes, sir.
Four
Four,
nodes.
four nodes. So for this circuit, to be exact, we have 4 nodes. Okay. So one is considered as reference node at the bottom, and you have node 1, which was represented by variable V1. That means voltage at node 1 is considered as V1. It is a notation we are giving. Okay. Voltage at node 2, we are giving a representation called as V2. If you see here, this 7 ohms resistor and 3 ohm resistor in between, you can consider as one node. Okay, so that will be your 4th node. But in the present circuit, if you can simplify this, you can simply add up this 7 and 3 and its series combination. So that will be a 10 ohms. Then you will have only 3 nodes. One is reference, another one is V1 and V2. Okay. So in this circuit, our objective is to find out only V1 and V2. So if you want you can simplify this circuit by simply combining 7 ohms and 3 ohms as a series thing called as 10 ohms. That means I can represent this entire combination by simply 10 ohms, and I can say that, okay, there are only 3 nodes. One is reference node, another two are two nodes are there, which is V1 and V2. Okay, that simplification can be done. Okay, so whenever you are applying nodal analysis, you have to do that simplification and then find out how many nodes are there. Okay, so out of all the number of nodes available, consider one as your reference node, and remaining 2 nodes in this circuit are V1 and V2. You understood, no? So when you are applying nodal analysis, try to simplify the combination. Okay, if there are series resistances, simply combined. Okay, only when in the question they have not asked this voltage, no? V4 they have not asked. That's why I'm combining. If they ask V4, then maybe you can combine and solve it. Then you have to find out V4 again. Okay. Okay. Anyway, for this circuit, okay, we are assuming that the series combination is already done, and we have only 10 ohms for this entire path. Okay. So if you consider that scenario, you have 2 nodes V1 and V2 and 1 reference node. So the total there are only 3 nodes. Okay. So I can draw an equivalent circuit for this. Okay, then you will observe that only 3 nodes are there. One is V1, V2 and V3. So I have not drawn here, but maybe you can draw and then do the solution for this. Okay, so what is the first step in the nodal analysis? Choose one as reference node considered as ground node or 0 volts. So in this circuit, this bottom node is considered as your reference node, which is at a 0 volts. Okay, and represent all other nodes with voltages V1, V2, V3, so on up to Vn. So that's what is done here. The voltage of node 1 is represented as V1. So that means the voltage of node 1 is V1 volts higher compared to your reference node. It is at a potential of V1 with respect to your reference node. Similarly, node 2. The voltage of node 2 is V2 volts with respect to your reference node. Okay, so that's what it means. So V1 and V2 represents the voltages of that particular nodes with respect to your reference node. Okay, so now we will try to solve this problem and find out V1 and V2. Once you know V1 and V2, you can find out current. Anyway, okay. So in the above circuit, one reference node and two non-reference nodes V1 and V2 are present. Since I have considered this 7 and 3 as 10 ohms. Okay. So that's why you have only two nodes V1 and V2. So how to solve this? Okay. Okay. So in the last example, somewhere you have seen I can apply nodal analysis at this node 1, and I can also apply nodal analysis at this node 2. That means current coming out of this node through branch 1, through branch 2, and current coming out of branch 3. That means between V1 and V2. So try to apply nodal analysis at node 1, you will get one equation, and try to apply nodal analysis at node 2, you will get one more equation, and the two equations will consist of V1 and V2. So there will be two unknowns and two equations. So you should be able to solve to find out V1 and V2. Okay, so try to apply nodal analysis at node 1 and find out what is your first equation. Okay, same thing you follow. All currents coming out of that particular node. You follow that scenario and try to apply. I will give you time, so try to do that. Find out equation 1 at node 1. Applying nodal analysis, which is nothing but KCL. All currents coming out of that node. You're trying to solve, right?
Yes, sir.
Yes, sir.
Okay. Find out equation 1 first, then we'll see, and then we'll go for equation 2.
Sir, V1 plus 2V2 is equal to 60.
That is equation 1.
Yes, sir.
Okay. Anyway, let's see that. So first of all, how you will approach? How you have approached?
I calculated series resistance of 7
Oh.
plus 3. As
Okay.
we did in the earlier example, I calculated through that, so.
Okay, so 10 ohms is the series combination of that one. So at node 1, you have 3 branches connected to it. One is 2 amperes current source, another one is 10 ohms, and the one is 15 ohms connected to node 1. Okay.
Yes,
So
sir.
how you have applied KCL or nodal analysis at that node 1? So how what is your equation? This first equation.
1 minute, sir. I've done a mistake here while calculating. I'll just confirm it again.
Okay. So how to approach this one is, okay, so I am considering this as 10 ohms, 7 plus 3. Okay, so if you see node 1, there are 3 branches connected to it. One is 2 amperes current source, another one is 10 ohms resistor, and the one is 15 ohms resistor. Okay, so when I talk about this node 1, all the 3 currents are coming out of that particular node, coming away from that particular node. That is what I am considering. Okay, so what will be the current coming out of the node 1 and flowing into 2 amperes? I mean 2 amperes current source branch. What will be the current leaving from that particular node in this direction?
Minus 2 ampere.
Minus
2, sir.
2.
Minus 2
Okay.
ampere.
So minus 2 ampere. That is one term you got. Next, what is the current leaving from node 1 and flowing to the reference node through the 10 ohms resistor? What is that value?
V1 by 10.
V1 by 10.
Okay. So V1 by 10, because we are considering all the currents coming out of the node. Okay. Right. So you have got minus 2, one term, and another one is V1 divided by 10. Next, what is the current leaving node 1 and flowing to node 2 through 15 ohms resistor? What could be that current equation?
V1
V1
minus
minus
V2 by
V2 by
2
15.
minus y V2 minus V1 by 15.
Minus V1 by
V1 minus
15.
V2 by
V1
15.
minus V2 by 15.
Okay, wait. Okay, so if you consider this 10 ohms resistor, what does this mean is V1 minus 0 ohms. 0 means reference is 0. V1 minus 0 ohms divided by 10 ohms. Okay, that 0 we have not written in the equation, that's why it is V1 divided by 10. So actually speaking, V1 minus 0 divided by this 10 ohms. Okay, because V1 is at a high voltage, let's say 5 volts. So it is at 0. So 5 minus 0 divided by 10. That is how you have written the equation for current flowing through 10 ohms resistor. If you consider the same scenario to find out the current flowing through this 15 ohms resistor, you have potential of V1 at this node 1, you have potential of V2 at node 2. Okay, so that V2 can be any value. We don't know that. That is unknown. We have to find out. So how the current is flowing? Current is flowing from V1 to V2. That means node 1 to node 2. If you see here, V1 is the potential and this is 0. So current flowing through 10 ohms is V1 minus 0. So from where you are starting, that will be positive, and where you are ending, that will be given a negative sign. Okay, so V1 minus 0 divided by 10. Similarly here, V1 minus V2 divided by 15. That should be the current coming out of node 1, flowing through 15 ohms and entering to V1, V2. Is it clear? So V1 minus V2 divided by 15. That should be the current flowing through 15 ohms branch. I hope I am clear, right?
Yes,
Yes, sir.
Yes, sir.
Okay. Because V1 is having some potential. That potential will try to, oppose the current flow. So obviously we'll have a negative sign. So V1 minus V2 divided by 15. So that is the current leaving the node. Okay. If I want current entering the node V1, that will be reverse. Okay. Anyway, we are considering only the current leaving the node 1, V1 minus V2 divided by 15. That will be the expression. Let's see what will be the equation at node 2. What could be that? If you say for 4 amperes, what will be the expression?
minus
Minus 4
So minus 4, next,
plus V2 by
plus V2 by 5
plus V2 divided by 5, next.
plus V2 minus V1 by 15.
V2 minus V1 by 15.
Yeah, so V2 minus V1 by 15. So same scenario, current flowing out of the node, okay, V2 divided by 5 minus 4, and if you say current flowing out of node 2, it is trying to flow from V2 to V1. So V1 will try to oppose your current, so it has some potential. So V2 minus V1 divided by 15. Okay, don't get confused. So from where you are starting, always put that as positive, and where you are running, that you put as negative sign, and divided by the corresponding resistor. Okay, let's see whether those are the equations or not. Okay, so if you see at node 1, it seems to be what we have discussed. So minus 2 plus V1 divided by 10 plus V1 minus V2 divided by 15. Okay, so if you solve this and get in terms of V1 and V2, you are getting some equation in this format. Okay, I hope you will be able to solve that. Okay, so we'll get this expression from applying nodal analysis at node 1. Okay, let's see what about node 2. Okay, so minus 4 plus V2 divided by 5, that is in, and V2 minus V1 divided by 15 is equals to 0. So all currents coming out of node 2 added up is equals to 0. So if you solve this, you will get this kind of expression. So there are two equations. One is equation 1 and equation 2, and there are two unknowns, V1 and V2. So I hope you should be able to solve it. Okay, simple substitution only. Find out V1 or V2 from one expression and write in terms of other expression and solve it. So you will observe that V2 is equals to 20 volts and V1 is also equals to 20 volts if you solve that. Okay, right. So basic thing is how to write these first two equations, equation 1 and equation 2. If you are very clear and if you write those two equations properly, then you have done major part of your problem solving, and remaining thing is simple substitution and solving. Okay, so if you do that, you will find out that V1 and V2 are equals to 20 volts. Did anyone get these values?
Yes, sir.
Yes.
Yes.
Okay, so writing these equations is only important. That is only critical part. Considering signs into account, considering direction into account, you have to write those things properly. If you do that, remaining thing is normal. Okay, so to have better practice, maybe you will have one more problem. Little bit complexity has increased. Okay, find the node voltages in the circuit shown below. Okay, so this is a circuit, right? If you see here, how many nodes are there? Can anyone say? Total nodes, including reference node. How many nodes are there?
5.
5.
2, 3, 5.
4.
4
Four nodes.
4 nodes. sir.
4 nodes.
Okay, so total there are 4 nodes. Okay, one is reference out of them, and 3 nodes will be there. Okay, so to avoid confusion, I will little bit modify this circuit. Okay, right, I can put in this fashion also. If you observe, I have not changed anything. I have just changed the wires or connections from here to here. So I have taken this 4 ohms resistor onto the top, extreme top. I am connecting to the same between the same nodes. Extreme top I have taken. That's all. And I have made this entire bottom line complete reference node as a single point. That's all. So no changes I have made. These two circuits are electrically equivalent. Only the way it was shown are different, but they are actually equal, similar. Okay. So from this circuit, I think you will have more clear picture. There is one reference node and 3 nodes V1, V2, V3. Okay. Right. So for this, you apply nodal analysis at node 1, you will get one expression. Nodal analysis at node 2, you will get one more expression. And nodal analysis as node 3, you will get one more expression. So try to write down all these three equations. Okay. Solving is normal thing. Writing equation is only important. So please try to write taking the current direction and polarity minus sign or plus sign, whatever it may be. Try to write the equation at node 1, node 2 and node 3. So I will wait for some time. So let's see what you will write and whether it will match with my calculation or not.
Sir, I have written all three equations.
All three equations. Okay. So what is equation 1? Can you say?
V1 minus V3 by 4 plus 3 plus V1 minus V2 by 3 plus 8 equal to 0.
Okay.
And second one is V2 minus V1 by 3 minus 3 plus V2 by 1 plus V2 minus V3 by 7 equal to 0.
Okay. Okay. Let's see. What about V3?
And the third one is V3 minus V1 by 4 plus V3 minus V2 by 7 plus V3 by 5 minus 25 equal to 0.
Okay. Okay.
The same equation.
Okay. Let's do that. Let's see whether those three equations are matching or not. Okay. Anyone others have tried?
Yes,
The
sir.
same.
Yes, sir.
Okay. Okay. So let's see whether those equations are matching or not. Okay. Okay. So first equation, let's consider node 1. How many branches are getting connected to it? You have 4 branches. One is this minus 8 amperes current source, 3 ohms resistor, minus 3 amps current source, and 4 ohms resistor. So 4 branches are getting connected. So you should have 4 terms in your equation. Okay. So first starting with this one. I want all currents to be coming out of that particular node V1. Okay. Node 1. So current coming out of the node V1, if you see here, minus 8 amperes is already given, which is flowing into the node. Okay. So what will be the current flowing out of the node in this particular branch? It should be minus of minus 8, so it will be plus 8. So plus 8 amperes is the current leaving node 1 and flowing to reference node. That means this current source is giving a term which is plus 8. Okay. Okay. So next, if you consider 3 ohms resistor, You have 3 ohms resistor between V1 and V2. So expression will be V1 minus V2 divided by 3 ohms. Correct. So next, minus 3 amperes current source is there. So current flowing out of the node 1 and flowing to node 2 through this current source. Okay, if you see, minus 3 amperes is flowing into node 1. So plus 3 amperes should be flowing out of node 1 to node 2. Okay, so we should have plus 3 volts. Okay, and coming to this 4 ohms resistor, it should be V1 minus V3 divided by 4. Okay, so is it clear for everyone?
Yes, sir.
Yes, sir.
Yes, sir.
So this is how you have to write your equation. 4 branches are connected, so 4 terms are required, and always try to follow the standard convention. All currents are coming out of that node. Okay, so if you consider that scenario, this is the expression you will get at node 1. Okay, if you segregate V1 and V2 into one direction and V3, you will get this expression, equation 1. Okay, so coming to node 2. At node 2, how many branches are there? Again, 4 are there. One is 1 ohm resistor, another one is 7 ohm resistor, one is 3 ohm resistor, and another one is minus 3 amperes current source. Okay, so if you start with the current source, minus 3 amperes is flowing out of the node V2, node 2. So current flowing into the node should be, okay, current flowing out of the node is minus 3 amperes, straight away it was given. So minus 3 amperes. Okay. So minus 3 amperes is flowing out of node 1. And next expression, if you see, V2 minus V1 divided by 3, V2 minus V3 divided by 7, V2 divided by 1 is equals to 0. Okay. Right. So this is how you have to write equation 2. Coming to equation number 3, at node 3, you have again 4 branches connected, 3 resistors, and 1 minus 25 amperes current source. Okay, so the current, right, so if you write here V3 minus V1 divided by 4, V3 minus V2 divided by 7, V3 divided by 5, minus 25 amperes is current flowing out of the node 3, so it will be minus 25 is equals to 0. Okay, so if you segregate it, you will get expression 3. So these are the 3 equations you will get for 3 unknown voltages which you need to find out. So there are 3 equations and 3 unknowns. You should be able to solve it. Anyway, we will see that. Is it clear for everyone how to write these equations?
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Does
Yes,
anyone
sir.
have
Excuse me,
doubt
sir.
in writing this?
Yes, sir.
Okay. So
Sir, how to sign, sir?
yeah,
Sir,
please.
how to write the sign conventions for that minus 25 ampere current? Said that plus 8 and plus 3 in node 1, minus 3 in node 2. Sir, I'm not clear about that, sir.
Okay. Okay. So coming to equation 1, that means KCL or nodal analysis at node 1. Okay. So first of all, this is your reference node. Okay. So we are assuming that the reference node is at 0 volts and V1 is some value. Okay. We don't know. V1 can be positive or negative, whatever it may be. Okay. We have given a representation that is V1. Okay. So if you see here, my objective is to find out what is the current leaving from that particular node through different branches. Okay. So there are 4 branches connected here. I should get 4 terms. That means 4 currents will be flowing out of this particular node V1. Okay. So if you consider resistor, V1 minus V3 divided by 4 is one equation. V1 minus V2 divided by 3, that is current flowing out of node 1 to node 2. If you talk about this current source, it was already given the current direction is upwards. Okay. So current direction is upward means current flowing into node 1 is given as minus 8 amperes. Here they are saying, no? So minus 8 amperes is the 8 amperes is the magnitude and minus 8. So that is the value of current which is flowing in this specific direction. Direction was given in this circuit. Okay. So according to this direction, minus 8 is the current flowing into node 1. But when I am writing the equation, my objective is always to write an equation such a way that all the currents are leaving the node. Okay, so if minus 8 was given in the circuit to be flowing into V1 or node 1, so what is the current flowing out of node 1 in this direction? Right. So in other words, you change the current direction in the circuit. That means you make this direction opposite. That means coming downward. When you change that, you have to change the sign for this fellow. Okay. So if you are changing this towards downwards, it will become plus 8. You're understanding or not? Okay. Hello?
Yes, sir. Confirm, sir.
Okay, in the circuit, the arrow is in the upward direction and the magnitude or the value given is minus 8 amperes. Okay, I want the current leaving the node 1 and flowing to reference node. So what will be that magnitude? It should be opposite to what it was already given. Okay, so coming down current will be opposite to what is there. So it will be opposite means it will be plus 8. So that's why I have written plus 8 here. Okay, here also same thing. Current flowing into node 1 is minus 3. Current leaving out of node 1 will be opposite to that. It will be plus 3. Okay, so if it is given minus in
So
this
sir, one main
direction, so
objective is to write the current which is leaving the node, sir.
what?
So sir, our main objective is to write the current which is leaving the node.
Yeah, you should follow one convention, standard convention. Okay, so I am following all the currents leaving the node. That is what I am following to the entire course. Okay, if you want to follow some other method, you follow that same standard for the entire course. Okay, right. But I am going to teach all problems with respect to this convention, all the currents leaving that particular node. Okay, this I am trying to follow, so that we also follow the same thing, so that we both will be in sync. We will have the same conclusion. Okay, so try to write current leaving that particular node whenever you apply nodal analysis or whenever you apply KCL. That will avoid your confusion. Okay, right. So you have to write, yeah.
Sir, in the
Okay,
previous
sir.
slide,
In the previous slide, this
sir,
one.
can we add the 2 ampere and 4 ampere and make 6 ampere as we did in previous examples?
If you make like that you can't do here, right? Why? Means if you have the current sources between the same pair of nodes, you can do that. Okay, but if you see here, this is node 1 and this is node 2. These two are not same. You have a 15 ohms resistor in between. When there is no 15 ohms resistor, then you can do. Okay, you understood, na? That
Yes, sir.
addition is possible only when you have current sources across the same pair of nodes. That means this terminal, this bottom terminal of both the sources are connected to same node. That is fine. But the upper terminal of 4 ampere source and upper terminal of 2 ampere source is not connected to the same node, because this is connected to node 1 and this is connected to node 2. So you can't add up in that fashion. Clear? That
Yes,
is
sir.
possible only the two are in parallel. That means they are existing between the same pair of nodes, then only you can do that. So here it is not possible to sum up. Clear?
Yes, sir. Thank you.
Okay. So I hope it's clear how to write the equation. Okay, so first thing you have to choose one reference node and denote
Yes,
the
sir.
variables v1, v2, v3, and you have to write the expressions for v1, v2, v3, and you will have 3 equations and 3 unknowns. You have to solve it. So I hope you will be able to solve that. Okay, so here I have given simple method. You can follow any method, whatever how you want to solve the 3x3 equation. Okay, so this is one method. So you know how to do this or not? Okay, so for these 3 equations, yeah, so v1, v2, v3, 3 variables are there. You have 3 constants, so these 3 constants will be written in the first row. For equation 2, the 3 constants, that is minus 0.333, 1.475 and minus 0.142328. So that will be in second row, and third row will be coming from this equation. So all the constants you will write. Okay, so that will be your 3 by 3 matrix. So you have to find out the determinant of this one. Okay. Next, if you want to find delta 1, okay, so what you have to do is you have to replace column 1 with your right hand side, minus 11, 3 and 25. Okay. Okay, remaining things remain as it is. If you want to find out delta 2, replace the right hand side variables constants with your second column. Second column will be replaced with this. I hope you know this, right?
Yes, sir.
You know how to find out determinant and how to solve a 3 by 3 equation, huh? Okay.
Yes, sir.
So you will find delta 2 and then you will find delta 3. So only thing is right hand side will be coming and existing in that particular column. Okay. For delta 3 it will be column 3. For delta 2 it will be column 2, and for delta 1 it will be column 1. So you'll have delta 1, delta 2 and delta 3. So now if you want to find out V1, it will be simply delta 1 divided by delta. Okay. So V2 will be delta 2 divided by delta. V3 will be delta 3 divided by delta. So if you solve that, you will get these three voltages. Is it clear? So I think this solving part of 3 by 3 matrix, 3 by 3 equations is known to you. Okay. So you have to find the determinant and then correspondingly divide to find out V1, V2 and V3. I hope you know this, so that's why I'm not stressing much on this part. Okay. So writing equation is important. Once you have done, it's a simple solving. So you should be able to do that. So you know V1, V2 and V3. So once you know V1, V2 and V3, you can find out current in any branch in the circuit. Okay. If I ask you what is the current in 1 ohm, simply V2 divided by 1 ohm. That will give you the current flowing through this. If I say what is the current flowing from node 2 to node 3, you should V2 minus V3 divided by 7 ohms. That is the current flowing from node 2 to node 3 through 7 ohms resistor. V2 minus V3 divided by 7 ohms. So once you know the voltages V1, V2, V3, you can find out current in any branch, and obviously you can find out what is the power absorbed or power delivered by any element. Okay.
Sir.
Yeah.
Sir, what is the current in 3 ohm? Then we consider minus 3 ampere.
No. Which current? Which current? Current
Sorry,
in
sir.
3 ohms resistor. Okay. So
Yes.
current means, always I told in the very starting, current means it is always with a magnitude and a direction associated. Okay. So if I ask you current flowing through 3 ohms, you no. If I ask you current through 3 ohms and simply leave it, you can specifically say current flowing through 3 ohms from V1 to V2. One answer will be there. Current flowing through 3 ohms from V2 to V1. You can give anything. Okay. Let's say I am asking you current flowing from V2 to V3 through 3 ohms. So what is that? V2 minus V1 divided by 3. If I ask you what is the current flowing from V1 to V2 through 3 ohms, that will be V1 minus V2 divided by 3. It's based on the direction. Okay. So direction will be, in both cases, it will be opposite. Let's say if in this case, if in one direction it will, let's say, how much?
Sir, minus
Okay.
3.
Wait. So current flowing from through 3 ohms from V1 to V2 I am asking. So what you have to do? V1 minus V2, that means 5.412 minus 7.73 divided by 3. So it will be some negative value. So what is that value?
2.
5.41 minus 7.73 divided by 3. Okay. So some negative value will come. So what it means?
Yes.
Let's say that negative value will, let's say minus x. I will call it as minus x. So minus x is the current flowing in this direction. That means V1 to V2. So plus x is the current flowing from V2 to V1. You understood or not? What is the value of that one?
Sir.
Did anyone calculate?
Minus 2.32.
Minus 2 point. I don't think.
Minus 0.7 something.
Okay, minus something like 0.7, because 5.4 minus 7.3 divided by 3, you will get some negative value, maybe minus 2.2 divided by 3 is something like 0.7, something like minus 0.7. So minus 0.7 is the current flowing from node 1 to node 2. Okay. In the other way, if you speak, plus 7 is the current flowing from node 2 to node 1. Understood?
Yes, sir.
Is it clear? Okay. So
Yes, sir.
if you find out current using okay, so that is how you have to find out the current in different branches. Okay, so if you find out current in one direction, oppositely the current flowing in the opposite direction will be negative of what you have found out. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Then next we'll see. One second. Okay. Next, see, we have seen nodal analysis and how to write the expressions for node currents or currents leaving from that particular node. Next, we'll see what is mesh analysis. Okay, so mesh analysis is basically with similar to your KVL, Kirchhoff's voltage law, but there is a slight difference between the two. Okay, we'll see what is that. Okay, so what is mesh analysis? An alternative method, sometimes easier to apply to certain circuits. So for some certain circuits, it will be easy compared to your KVL. Okay, so mesh analysis is applicable only to those networks which are planar. Okay, so what it is saying is mesh analysis is applicable only to those networks which are planar. Okay, so what is planar means? Okay, planar circuit. Okay, if it is possible to draw the diagram of a circuit on a plane surface in such a way that no branches passes over or under any other branch, then the circuit is said to be a planar circuit. That means you should be able to draw a circuit on a plain paper, okay, on a surface, and the condition is one branch should not overpass or underpass other branch. Okay, if you are able to draw a circuit in that fashion using this condition, not following this condition, if you are able to draw a circuit on a plane surface, then that circuit is called as a planar circuit. Okay, so here there are 3 examples. Okay, so let's see whether which is planar or not. So what do you feel like circuit A is planar or not?
Yes, sir.
Planar.
Planar.
Right. Why means because you are able to draw the diagram for that circuit on a plane surface. There are no branches which are overpassing or underpassing. What about figure B?
Non-planar.
Non-planar.
Not planar. Why means if you see here, this is a point where one branch is overpassing or underpassing one particular branch. That means one overlap is going to take place, one over the other. Okay, so that's why it is non-planar. What about this one?
Non-planar.
It is planar. How you are saying it is planar? Why it is not? It is non-planar or planar?
Non-planar.
Non-planar.
Okay, so most of you might have feel that it is non-planar, but I have written C is also a planar. Why means if you observe here, this branch is overpassing this particular branch. It seems to be overpassing, but if you more exactly check, it is not overpassing because I want to draw the circuit on a plane surface. Okay, so I can pull this. They are not interconnected. Okay, these are not interconnected. One is passing over the other. I can pull this resistor onto this point. I can draw a circuit in this fashion also. That means outside this box. You are understanding or not? I can pull this power passing
Yes, sir.
resistor
Yes,
at
sir.
this point,
Yes, sir.
and I
Yes, sir.
can draw the circuit on this fashion. Okay, so that means without overpassing or underpassing, I am able to draw the circuit C also on a plane surface. So that's why this C is also a planar circuit. So just to make you clear, I have drawn in such a fashion. That's all. Okay, so circuit A and circuit C are planar circuits, and circuit B is a non-planar circuit. So mesh analysis is applicable only for planar circuits. For non-planar circuits, mesh analysis is not going to work. It is not valid for non-planar circuits, valid only for planar circuits. So whenever circuit is there, first you have to check whether it's planar or not. If it's planar only, you have to apply this one. If it's non-planar, there is no other option, you have to apply KVL only. Okay, so that is the difference between mesh analysis and nodal, KVL. Anyway, we'll go into that, then you will understand. Okay, so they are saying one more statement. Mesh, it is a property of a planar circuit. First of all, it's a planar circuit and is undefined for a non-planar circuit. For non-planar circuit, it is undefined. So you can't work mesh analysis on a non-planar circuit. Okay, next what it is saying, we define a mesh as a loop that does not contain any more loops within it. Okay, so mesh analysis is applicable for only planar circuits. Next, what you have to do is you have to define a mesh. Okay, in a KVL, how you have defined a loop. Okay, similarly here you have to define a mesh. Okay, so what you used to do in KVL, the first step in KVL is to determine the current direction in different branches. That is the first step you have to do in KVL. Next, you have to give the polarity for different elements. That means when our current is flowing through some resistor, the entering point is considered as plus V plus potential and the leaving point is considered as minus potential. So once you determine current and next you determine the potential across different elements, okay, then only you can apply KVL to that particular loop. Okay, so that is KVL for a loop. When you talk about mesh, okay, we define a mesh as a loop that does not contain any more loops within it. So that means you can call a loop as a mesh only in such a scenario that there are no more loops within it. Okay, I hope I am clear. Mesh will not contain any more loops within it, then only we will call it as a mesh. Okay, observe the dark line part in the below planar circuits and understand regarding mesh in a circuit. So if you see here, there are two circuits given here, both are planar circuits, both can be drawn on a plane surface. So if you see this dark line, this highlighted line or solid line, if you see, dark line part is not a mesh. Why? It is not called as a mesh because it consists a loop within this. This loop exists within this mesh. This loop exists within this loop. So you can't call it as a mesh. Okay. So what they are saying, mesh is a loop that does not contain any more loops within it. Okay. So if you see circuit 2, this can be called as a mesh. Why means there are no more loops within this loop. So that's why this loop is called as a mesh. Is it clear? So mesh is one which should not consist of any more loops within it. Then only you will call it as a mesh. So in circuit 1, the solid line is not a mesh. In circuit 2, the dark line part is a mesh. Is it clear?
Yes, sir.
Yes, sir.
Is it clear to everyone?
Yes, sir.
Okay. So mesh will be only a loop which does not contain any more loops within it. Okay. So mesh analysis techniques involves the concept of mesh currents. Okay. So for analysis of mesh analysis, we have to first find out one mesh and then involve the concept of mesh currents. Then you have to define mesh current. Okay. So we'll see that what is that. So this is the circuit they are given. Okay, so you can apply any method, KCL, KVL, nodal analysis, whatever it may be. So mesh analysis is one of those techniques. Okay, so determine the current through each resistor in the circuit shown below using mesh analysis. That is the question. Current through each resistor. Okay, current flowing through 6 ohms, current flowing through 4 ohms, current flowing through 3 ohms. They are asking us to find out. Okay, we are trying to use mesh analysis to understand that. So what they are saying, in mesh analysis you have to define mesh currents in each mesh. Okay, so if you see here, how many meshes can be formed from this circuit?
Two mesh.
Two meshes. Okay, one mesh is, let's say, to 42 volts, 6 ohms resistor and 3 ohms resistor. This is called as mesh 1. Another mesh is 3 ohms resistor, 4 ohms resistor and this 10 volts. Okay, right. So these three elements will form one mesh and these three elements will form one mesh. But this bigger loop consisting of 42 volts, 6 ohms, 4 ohms and 10 volts, we will not call it as a mesh. Okay, so you can't apply mesh analysis for this larger loop. Okay, but you can apply KVL for that. Okay, so for applying KVL you have to determine the branch currents. For applying mesh analysis you have to determine mesh currents. They are asking us to, in mesh analysis you have to define mesh currents in each mesh. Okay, next what you have to do, we have to apply KVL to each mesh using the defined mesh currents. We no longer have branch currents in the circuit. So what they are trying to say is, there is no concept called branch currents in mesh analysis. There is only concept called mesh current. So using mesh current, you will try to solve all the mesh currents, find out all the mesh currents. From that, you can find out the branch currents if you want. Let's see that. Okay. So if you see the circuit, there are two meshes and two mesh currents were defined. One is in the clockwise direction with notation of I1 and another one is clockwise direction with a notation of I2. So two mesh currents are there. Okay, so now you have to apply KVL for mesh 1. So how you will proceed? What could be the expression?
minus 40
Okay,
plus 6 I1
okay.
0
What is the third term?
plus
Okay, so
I1
you
minus
are
I2.
saying that you will start. Okay, we'll see that. So you are saying that you are starting at this point and flowing in the clockwise direction and completing on complete round 360 degrees. So first you have encountered 42 volts with a minus sign, so minus 42, that is correct. Next, this will be encountered, you will consider that as plus, so plus 6 ohms, that is also correct. Next, if you come to this point, since the current is flowing, mesh current is flowing in this direction from top to bottom. Okay, so plus will be considered here. So plus 3 into I1 minus I2, because I1 is trying to flow from top to bottom, I2 is trying to flow from bottom to top. So those two mesh currents are opposite to each other. Since you are considering mesh 1 and the mesh current direction is you are considering for mesh 1, so this is considered as superior. So you will have I1 minus I2 into 3 ohms. I hope I am clear. Is it clear to everyone?
yes sir.
Yes, sir.
Yes, sir.
Okay, because the two mesh currents what you have defined for branch 3, for this middle branch, the two currents are seen to be opposite. Okay, and since you are applying KVL for mesh 1, so you will consider I1 as positive, I1 minus I2. I1 current is top to bottom. If you consider that as positive, I2 current is bottom to top, so it should be negative. So I1 minus I2 into 3. So that is should be the expression for mesh 1. Okay, what will be the expression for mesh 2? Start at this point.
4I.
Starting at this bottom point. Okay, 3 into I2 minus I1, because you are applying mesh analysis for mesh 2. Okay, so I2 will consider it as a superior. That means this is a superior fellow. So you will consider 3 into I2 is positive minus I1 plus 4
Plus
into
4I2.
I2 plus 4I2 minus 10 is equals to 0. So that should be your expression. So if you see here, okay, applying mesh analysis for mesh 1, minus 42 plus 6 into I1 plus 3 into I1 minus I2. I1 and I2 are opposite to each other. and you are applying mesh analysis for mesh 1. So I1 is considered as superior, so I1 is positive. I2 is opposite to I1, so minus sign will come, so minus I2. So that is your expression. If you solve that, you will get this equation. Similarly for mesh 2, let's say, okay, starting at this point, and you can start at any point, you have to complete 360 degrees, that's all. So 4 into I2 minus 10 plus 3 into I2 minus I1 is equals to 0, right? So if you solve this, you will get equation 2. So 2 equations, 2 unknowns you should be able to solve. So I1 and I2. So I1 you got it as 6 amperes, I2 you got it as 4 amperes, right? Is it clear to everyone?
Yes, sir.
Yes, sir.
Yes,
Okay. Okay, so now you remember that I1 and I2, what you have calculated using this mesh analysis defines the mesh current. They are not the branch currents. They are mesh currents. Now my question is, what is the current flowing in 6 amperes? If I ask you, what will be the current? 6 amperes.
6 ampere.
Current flowing from left to right. Direction also I'm saying current flowing from left to right through 6 ohms resistor. What is that?
6
6
ampere.
6
ampere.
6 amperes. Why means this mesh current is the current flowing in this direction, and there is no opposition current which is flowing in this 6 ohms resistor. So I1 will be equals to current flowing through the 6 ohms straight away. That will be 6 amperes. What is the current flowing through 3 ohms resistor from top to bottom?
2 ampere.
2
2
ampere.
ampere.
2 ampere.
2 ampere. How? Current flowing from top to bottom, if you see, this is the current. I1 is flowing from top to bottom. What about I2? Flowing from bottom to top. I1 magnitude is 6 top to bottom. I2 is observed to be 4 from bottom to top. So the difference between those two will be the current flowing from top to bottom, which is 6 minus 4, that is equals to 2 amperes. Right. So I6 ohms is equals to I1 is equals to 6 amperes, I4 ohms is equals to 4 amperes, I3 ohms is equals to I1 minus I2 is equals to 2 amperes flowing from top to bottom. Is it clear? So once you know the mesh currents, once you find out the mesh currents using solving these two equations, you can find out the branch currents using this understanding. Okay. Is it clear?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
Okay. Okay. So this is one more example. Okay. So quickly we'll write the equation, and solving part I will leave it to you. You can do that. Okay. So what is the equation for mesh 1? Start at this point. How it should approach? You should get minus 7 first. So you got minus 7. What about the current flowing in this 1 ohm resistor? What will be the expression? If you see here, I1 is in this fashion. I1 is from top to bottom. I2 is seen to be opposite to that. So I1 minus I2 into 1. Into 1 I have not written. I1 minus I2. Okay. Next, coming to this part, you are closing your loop in this fashion, right? So you are encountering plus 6 ohms initially through I1. So that is plus 6. What about this one? It should be V is equals to I into R. R is 2 ohms. So 2 is written. What is the current flowing? Net current is I1 from top to bottom, I3 from bottom to top. So I1 minus I3. Is it clear?
Yes, sir.
Okay.
Yes.
Okay. So for here, if you see for mesh 2, it will be I2 minus I1, because I2 in this direction, I1 in from top to bottom, so I2 minus I1. So wherever which mesh you are considering, that current is considered as superior. Okay. So you start I2 as positive, I1 as negative, so I2 minus I1 plus 2 into I2 plus 3 into I2 minus I3. That is your expression. So if you solve that, you will get equation 2. What about third one? Starting from this point, you have 2 into I3 minus I1 minus 6, since minus sign is seen at the first. Okay. Minus 6 plus 3 into I3 minus I2, that is there. And last one is I3 into 1, which is nothing but I3. Is it clear how to write equations for all the three meshes?
Yes, sir.
Yes, sir.
Okay. Okay. So that is how you have to write the equations for all the three. Then after that, it's solving three equations with three unknowns. So you will be able to find out I1, I2, I3. So you get I3 is equal to 3 amperes. That's it. So in the mesh analysis, find the three mesh currents. So you know you will be able to find out I1, I2, and I3. Is it clear or anyone has doubt?
No, sir.
Clear, sir. Clear.
Yes, sir.
Clear, sir.
So if you have doubt, your recorded video anyway will be sent to you by evening. So you check all the problems again and try to write the equations on your own and find out the solution and cross check whether you got the same thing or not. Okay. So that's it for today. So DC part is done. Part 2 will start from tomorrow morning 9 o'clock. Tomorrow we have class, right? So we'll start and prepare well. This Friday you may have an exam on DC circuits. Okay, so prepare well for that. Okay, that's fine.
Okay, sir.
Yes, sir. Okay.
Sir.
Okay, sir.
Okay, then so that's it for today's class. Okay, take care. Bye.
Thank you, sir.
Okay, thank you. Yeah, anyone has doubt?